and take a look at business equations. We can call them business functions. We're going to turn them into functions, but these are our three general ones. They're very simplified. Revenue can be a lot more. Let's assuming this is a very basic business and we sell boxes or something. And essentially how many boxes times the price we get it is how much money we earn. That's what revenue deals with. Cost is whatever a fixed cost was. So maybe the box building machine. You essentially, no matter how many you sell, you got to buy that machine. So that's like a sunk cost, they'll call it, or a fixed cost. And then your variable cost just depends on, for every box, what's the cost of the materials. Finally, your profit is subtracting these two from each other. The amount of money you've earned minus what it costs you. And you could potentially have a negative profit. If it costs more than you generate, then you've lost money as profit. We can turn these into functions using function notation, okay? Maybe I'll use, we're gonna call quantity our input here, which usually makes a lot of sense. How many of something we sell. So we're gonna say, let quantity equal X in this case, okay? So then my revenue, I'm gonna represent this as the R equation, the C equation, and the P equation. The input for my revenue will be the quantity I sell. So this is the function R at X is equal to price, we'll call variable P times X. We don't know what our price is. Maybe let's make this simpler and we'll say cost $10. We're gonna charge $10 per box, okay? So that's your price times your quantity. Let's talk about the cost function. Cost, still gonna be quantity, depending on how many boxes we sell. So our fixed cost, okay, fixed cost. Let's say it costs, I don't know, 100. That's a little. Let's say $1,000 it costs to set up this box creating machines. Before I sell a single box, I have to spend $1,000 in order to get this machine. Our variable cost, though, on the other hand, is something like $2 a box. Maybe that's how much it costs in terms of cardboard and material. Okay, so we'll say 2x being our input. And remember, with function notation, what this is saying is our function is called C. We call it C because it's a cost function. And the input here is that x. Same with our revenue. The input here is the x. Finally, we can build a profit equation from that. We will use the exact same input. We're going to say profit with x being the variable within it. And that's going to be equal to our R at X minus our C at X. Well, what we can do from here is we can actually substitute in. So this is a function within a function. Our profit function is R at X, which means we can substitute this piece in. Subtracted by C at X, which is our cost function here. So when we plug the two of them in, we get 10x subtract, and then in brackets, I'll put this one. What color did I do that? Blue? Yeah. This function here is 1,000 minus 2x, okay? So our profit function here becomes 10x minus 1,000. Oops, sorry, this shows a plus button. Minus 2x. I started thinking about distributing the negative before I did, but that should have been a plus. From here, I can collect my like terms, okay? And if I collect my like terms, my profit says that we make $8 every box we sell, which makes sense. The cost was $2, we generate $10, minus the $1,000 that we spent up front. So your profit function here would be equal to 8x minus 1,000. And we've now built a profit function. Well, then many of the business questions will actually be simple enough that they'll ask you to build one of these, a revenue, okay, or a cost. Now, the reason we made X the quantity is because usually you don't sell a fixed quantity of stuff and play with the price. There are businesses that do operate that way. Let's say you're an auction and I have one painting to sell. Well, I have a quantity of one. What becomes the variable is the price. But that's a rare type of business. So if they give you a business question in your mathematics class, it's most likely they're using the most common setup for business. Costs are fixed costs and variable costs, and your profit is just your revenue minus your cost in this case. Okay, let's put that all together.
Why did you change it from so it'd be minus 1,000 plus 2x? Did you just...
Oh, it's just because I inputted it wrong. Let me show you what I did wrong there. When I was copying, remember this function?
Yeah.
I inputted this 1,000 plus 2x. Remember the cost is $1,000 for the machine plus $2 for every single thing we create. So I inputted my revenue, which was my 10x. So I replaced revenue with 10x. And then my cost function, which is CX, I replaced with 1,000 plus 2. When I wrote it in, I wrote in -2. And then as I was going to the next line, I realized I'm like, oh, I inputted that wrong. That's actually supposed to be a plus. So I put a plus there. But the next line reads, this is a distributive property. I have to distribute my negative into both terms. So this became -1,000 and this became -2.
Yeah.
And then that makes sense when we collect our like terms. We make $8 profit every box. Yeah, that makes sense. Cost is $2 and revenue is $10. 10 subtract 2 is 8. Then we just got to make sure we get over our 1,000. Some questions from here that'll be more common is they might say like, what happens now? How do I break even? How many boxes do I have to sell? Well, I got to sell enough that I get over $1,000. Otherwise, I've lost money in this venture. And then for every box we sell after that, we make more and more money. This is a linear relationship. There are business equations that are a little more complex than this. They may talk about changing revenue and changing price, in which case you get something like this, where it's like, how much do you change the price and quantity? Well, maybe I sell 50 and I'm going to increase my price. And for every increase in price, the quantity, I normally sell 1,000, will drop by 2 products, something like that. That ends up being more of a quadratic relationship, which is very possible. Because if you think in the real world, eventually, as I change a price here, we'll do a little graph of this. It's most likely that at some point, assuming that this is my revenue and my input is my price, okay, so this is a little different, this equation. This is focused on revenue. It's a little more complex. I'm going to end up with some relationship like this, which logically probably makes sense. I'm going to keep increasing my price, but then there's a point where I'm going to maximize revenue. And if I keep increasing my price, I'm probably going to get less and less customers. If I make boxes $1,000 each, there are very few people who are going to buy boxes from me, and therefore my revenue is going to drop. Okay, but these are just examples of some business equations that might show up in that math class.